Okay, today we are going to be solving or estimating the following differential equation at point x of 1. And we're going to be using Euler's method to estimate it because this is a little problematic because it has two variables here. Can't really separate that. So we're going to use Euler's method at 4 different step sizes, step size of 1, 2, 4, and 8. So for step size, let's make a little chart of values of our step number, our x value that we get, and our y value that we get in order to plug it into the formula. So we only doing one step size, so and we're gonna end up getting this. So let's put this into Euler's method. So for our y initial, it is, well, 0, so we're just gonna put this here. And then for our height, we're just gonna put 1. And then for we're gonna put our 0 and 0 into the derivative, and sine of 0 is 0. That's just 1, so y of 1 is 1. Okay, so this isn't really that accurate, so let's do another step size. So let's do a step size of 2. Let's go ahead and branch this off. Step size 2. So at a step size of 2, I'm going to get an h of 1/2. So let's do this: 0, 1, 2, 1/2, and 1. So start out with our first iteration here. Just going to be y of 0, just 0. I'm not going to write it down, and then we're going to put our height, which is 1/2, and we're going to solve for f at 0, 0. Just going to yield 1/2. Let's do our next iteration, which is just 1/2 plus 1/2. The derivative at 1/2 half. That's just going to give us 1.12. Okay, now let's do it at a step size of 4. So at a step size of 4. Okay, for a step size of 4, excuse me, okay. For a step size of 4, we'll be doing 4 steps, so that's just going to be 0, 1, 2, 3, and 4. Right. And then let's put this here. Alright, so what is going to be our heights? That's just going to be 1, 0 minus 4, so our heights are just going to be in quarters. Okay, let's write that down. I wrote this down in decimals, so alright, let's plug that in now. So y of 1 is equal to, that would just be 0.25, f at 0.25, 0.25, which is going to be, well, that's just 0.25. Alright, next one, y of 2 is going to be 0.25 plus 0.25. Wait, oh. Can you see it there? It's not 0.25, that's the initial 0, yeah. Okay. So f at 2.5. Then now we do f at a quarter and a quarter. And I got 0.54. Let's just go ahead and write these next ones down. 0.504 plus quarter f at a 504. 0.504. Okay, and 0.504 yields 0.785. Now for our last point of step size 4, it's going to be 785 plus 0.25 f of 0.75 at 0.785, which gives us 1.139. Okay, well that's a little different, so we're almost to a more exact value. Let's just do it at step size of 8. Move the camera over here. At a step size of 8. And so at 0, 1, 2, 3, 4, 5, 6, 7, 8. And we're going to be doing this at little steps of 1/8 size, so that's just going to be 0, 1.25, 0.25, 0.375, then 0.5, 625, 75, 875, and 1. Okay. So let's go ahead and start solving this. So go down here. Y of 1 is going to just be our 0. So 1/8. F at 0, 0 is going to be 1/8. Then before we start writing this down, let's go back up here. 1/8. Okay. So this is just going to be 1/8 plus 1/8 f at 1/8, 1/8. And plugging that in gives me 0.2502. 2502. All right. And then going from point y equals 3, 0.2502 plus 0.25 at f of 0.25. .2502, and that gives me 3.377. All right. Well, I'm just going to go ahead and write out the next values. You can verify these on the calculator if you want. But continuing this sequence, we get next 0.509, and we get 0.65, and then we get 0.806, and we get 0.984, and then finally we get 1.19. So those are the approximate solutions for x at 1 for each of those step sizes. So yeah.